Okay, good morning. Welcome to
MathIdeas98.
MathIdeas98. Today we're going to be learning a new thing. It's not a problem like we usually do in these videos. Today we're going to be learning about counting in binary. Excited about that?
Yeah.
It's a different way to count. Have you ever heard about binary before?
Yeah, I think you did a movie with
With your brother?
Yeah.
Yeah. Okay. All right. Well, let's take a look at what counting in binary is. When we write down a normal or a number the way you're used to seeing them, like 247. Do you know what 247 means when we write it down?
It means 47 over 200.
Not 47 over 200. It means 200 plus 40 plus 7. Right? And which is, we write these as powers of 10. It's 2 times 10 times 10 plus 4 times 10 plus 7. Okay? So how about, what do you think it means when I write down the number 529? What does that mean?
It means 500 plus 20 plus 9.
500 plus 20 plus 9, which is 5 times 10 times 10 plus 2 times 10 plus 9. So we use, in the normal counting system, we use powers of 10, and you get used to that, right? So if I wrote down this number, 7,643, you know what that means, right? What does that mean?
7,000 plus 600 plus 40 plus 3.
7,000 plus 600 plus 40 plus 3. So 7 times 10 times 10 times 10 plus 6 times 10 times 10 plus 4 times 10 plus 3. So we keep using powers of 10, and powers of 10 seem really easy, right? Okay. But we don't have to use powers of 10. The simplest thing we can do is use powers of 2. 2. 2, 2, 2. Powers of 2. Okay. And first we have to say what powers of 2 are. But it's actually not too hard to figure out. 2, when you have just one 2, that's equal to?
2.
Right. Now remember that. 2 is equal to?
2.
Okay, I'm going to give you a test. Ready? What is 2 equal to?
What?
What is 2 equal to?
2 equals 2.
Right. Very good. 2 times 2, you know what that is. What is that?
It's 4.
4. 2 times 2 is 4. 2 times 2 times 2 is?
It's 6. No. And 2 times 2 is?
2 times 2 is?
Is 4.
Times 2 is?
6. No.
4 times 2 is?
4 times 4 sets of 2 is 8.
Right.
8.
Just 4 plus 4. This is 8. Let's do one more. 2 times 2 times 2 times 2 is 8 times 2. And what is 8 times 2?
16.
16. Very good. Okay. So, in our normal system, like when I have 569, I can use the digits 0, 1, 2, 3, 4, all the way up to 9. But when I have powers of 2, all I'm going to do is use the digits 0 and 1. This is called base 10. This is called base 2. So we're going to spend a few days talking about base 2 just for fun, okay? Okay. So we're only going to use the digits 0 and 1. So when I write a number in base 2 like this, 1, 0, 1, base 2, I mean this is just 1. This is 0 times 2, and this is 1 times 2 times 2. Okay, now that might seem confusing. We start out with the 1's digit, the 2's digit, and the 4's digit. 2, 4, 8, 16. Let me show you what if I just wrote 101 and I was talking about base 10, the normal way we think about this. What would you say this number was?
I would say it was...
You would say this number was 100? plus how many tens?
Plus 1.
Plus 0 tens.
Yeah, plus 0.
Plus 1. In other words, you would say this is 1 times 10 times 10 plus 0 times 10 plus 1. You would say this number, 101, was 1 times 100 plus 0 times 10 plus 1. But in binary, in base 2, we just say it's 1 times 2 times 2 instead of 10 times 10. Plus 0 times 2 instead of 10, and then the 1 stay the same. Okay? So what about this number? Can you just tell me what this number is? 1, 0, 1, 1 in base 2. Okay? What does this represent here, this 1?
This one represents the tens place. No,
The ones.
the ones.
This is 1. This is the 2's place, so that's 1 times
It's 1 times 2.
1 times 2. This is 0 times
0 times 4.
4. And this is 1 times
1 times 8.
1 times 8. So this is, let me write it a little more clearly, 1 times 8 plus 0 times 4 plus 1 times 2 plus 1. Okay? Well, let's look at what this number is. This is 8 plus 0 plus 2 plus 1. And what is that? What is 8 plus 2 plus 1?
8 plus 2 plus 1 is 11.
It's 11. 11 in base 10, the way we normally know it. So this is a funny way of writing the number 11. Isn't that strange? Okay, so let's see if we can let's see if we can count to 10 in binary, and that'll be our binary for the day. Okay? Well, the first number, 1 base 2, is just 1. But now the question is, how do I write 2? Oh wait, we have a 2's digit, right? So I write 2 just by writing it 1, 0. This means 0 times 1 plus 1 times?
Plus 1 times 1.
1 times 2.
And 1 times 2.
Okay? 1, 1 base 2 is 1 times 1 plus 1 times?
1 times 2.
1 times 2. And so I get 1 times 2 plus 1 times 1, which is?
Which, well, 1 times 2 is just
2. And 1 times 1 is?
1. That's 3.
This is 3. Look at that. And now look at this one, 1, 0, 0. Well, this is 0 times 1 plus 0 times 2 plus 1 times?
2.
1 times.
1.
Remember, our digits go 1, 2, 4, 8, 16. So this is the 1's digit, the 2's digit, this is the 4's digit. 1 times 4 plus 0 times 1 plus, or 0 times 2. 0 times 1. 1 times 4 is?
1 times 4 is 4.
0 times 2 is?
0.
0 times 1 is?
0.
So this is 4. Now what number comes after 4?
5.
Right, and so we're going to write 5 as 1, 0, 1 base 2. So this is 1 times 4 plus 0 times 2 plus 1 times 1. See that? 1 times 4, 0 times 2, 1 times 1. What is that?
It's 5.
5. Okay. Now 6 is going to be 1, 1, 0 base 2. 1 times 4 plus 1 times 2 plus 0 times 1. That's 6. Isn't this a funny way of counting? 1, 1, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 1, 1, 1, 0, I mean?
That's a funny way.
That's a funny way. What do you think comes next? How do you think I make a 7? This crazy number equals 6. What do I have to add to 6 to get 7?
1.
1. So where do I put a 1? Right there. Right, good job. So 1, 1, 1 base 2 is 1 times 4 plus 1 times 2 plus 1 times 1. Well, 1 times 4 is?
1 times 4 is 4.
Plus 2. 4 plus 2 is?
6.
Plus 1 is?
7.
7. Okay, well, why don't we stop here for now, actually?
Okay.
Okay? So this is a completely new way of counting. Now, this looks like kind of a silly way of counting, doesn't it?
Mm-hmm.
Who would count like this, do you think? Why would anybody count like this?
Wow, this is crazy.
It is crazy. It's so much easier just to go 1, 2, 3, 4, 5, 6, 7, right? Instead of 1, 1, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1.
Yeah.
This is how computers count.
Cool.
You know why computers count like this?
Why?
Because they don't have any fingers. So they can't go 1, 2, 3, 4, 5, 6, 7. Is that silly? This is how computers count. So if you're going to learn a little bit about computers, this is you have to learn a little bit how they count. We'll talk about this. This is kind of a fun thing to talk about, I think, don't you? All right, good job.